Hello class. We are working in the big book on page 148 and we're working on problems that are taking improper fractions and making them into mixed numbers. So just to review, an improper fraction is a fraction where the numerator, number on top of the fraction bar, is larger than the denominator. And a mixed number is a number that has both a whole number and a fraction. And just to remind you, like I said, the most important thing that you're learning in 5th grade math is that fraction bar means to divide. So on the top of page 148, we have the problem 8/5, and it's asking us to make that into a mixed number. So our problem is really 8 divided by 5. You could do that as a division problem, but I also want to show you with some pictures what that actually means. So here you see I have pies with 5 pieces in them. And we need to count 8 of them. So if I'm looking at this first pie, I've got 1, 2, 3, 4, 5, and then I'm going to go on to my second pie, which is broken into fifths, 6, 7, 8. One of the hardest things about this was drawing my circles. So as you can see, I've got 8 pieces of fifths, and we can count them. 1, 2, 3, 4, 5, 6, 7, 8. So it wants us to put that into a mixed number. So what we're having to do is see how many full pies we have. Well, we have 1 full pie here, and we have 3 pieces left over, because that's 5 plus 3. So that means we have 1 whole, 3 pieces left over, and that pie was split into fifths. So that's how we make that improper fraction into a mixed number. Let's do number 2. Number 2, the problem is 13/5, and it wants us to know how can we make that improper fraction into a mixed number. So I've drawn my pies all split into pieces of 5. So you'll notice each one of these has 5 pieces. That's what 1/5 means. And we have to color in 13 pieces. So I'm going to color in 1, 2, 3, 4, 5. That's 5 pieces. 6, 7, 8, 9, 10. You can see my pieces aren't perfect, but that's all right. So that's 5. And then another 5 there, and we have to get up to 13. So we're going to color 3 more from this one. 1, 2, 3. So now we've proven we have 5 plus 5 plus 3. That's 13, and they're split into fifths. So now it's asking us, how many full pies do we have? Well, we've got 1 here. We've got 1 here. So we have 2 full pies. And then we have 3 1/5 pieces left. So we have 2 and 3/5. That's how we make that a mixed number. Could we do this as a division problem? Sure. It's 13 divided by, 5. So, and if you know your times tables, you know right away that 5 times 2 is 10. That's going to get us closest to 13. 5 times 3 is 15. That's too much. So if we think about 2 times 5, gets us to 10. So we know 5 fits in the 13 2 times. And then how many are left over? 3. And that's 3 of the fifths. So this is kind of a new idea for you, that our divisor becomes our denominator. But once again, that's what that fraction bar means. Okay, let's do one more problem. We're working on page 148, number 3, and the problem is 11/5. So I've got my pies here. Again, not for perfect circles, doesn't matter. You're just sketching it out. So that's 5 pieces there. That's 5 pieces there. I need to get it to 11, so I know that 5 plus 5 is 10, so I'm going to need one more. So I've got 5 here, and one more there. That's my 11 pieces of fifths. How many full pies do I have? I've got one here, and just one piece there. So that gives me 2 full pies and 1 piece of the last pie. So that's 2 1/5. Again, you could have done it as a division problem. 11 divided by 5. You know that 5 fits into 11 2 times. 2 times 5 is 10, and there's 1 left over. That's 1/5. Okay. I'm going to show you the answers for the rest of problems 4, 5, and 6. You can work them on your own. And maybe you can't see that so well. Scooch it up a little bit. Number 4, the answer is 2 2/5. Number 5, the answer is 1 1/5. And number 6, the answer is 2 4/5.